Thanks for coming. Welcome to this fireside chat on data at scale. And my name is Brian Walters. I'm going to actually let each of our panelists introduce themselves as well. Each person up here has, well, the kind thing to do would be just say a lot of experience behind them, but I think we're ranging in the double digits. You know, speak for myself, almost 30 years of experience in the industry, and let them speak for themselves. But let's go ahead and start here on my left.
Yeah, hey everyone, my name is Shaw. I'm currently CTO at Catalyst into Tango. We actually just went through a recent merger about 6 or 7 months ago, so that's why it's Catalyst and to Tango. We're in the customer success platform space, and Catalyst, you know, I was with Catalyst for about almost 4 years. Prior to this, we were a fast-growing company. Basically, we bring in a lot of data on behalf of our customers, and we really try to give them insights around upsells, expansions, renewals, but we bring a very diverse set of data from Salesforce, CRMs, as well as product usage, things like Pendo, Mixpanel, things like that, as well as just any flavor of data warehouse, ticketing systems, and the like. And we try to put 360 view together where our customers can drive their workflow automation off of, and basically we'll talk a lot more about our use cases, I'm sure, during the session. Prior to Catalyst, I was VP of Engineering at GitHub. There I managed core platform billing, so a lot of our authentication, authorization, billing, as well as our ecosystem and community team. So that's anywhere from marketplace to APIs, webhooks, and things like that. And then prior to GitHub, I was VP of Engineering at SendGrid for about 4 years. I joined 6 months after our Series C, and I was there. Basically, I was part of the team that took the company public back in 2017, and then I stayed until the Twilio acquisition.
Very good. Lucas.
Hello, everyone. My name is Lucas. I'm the director of the foundation engineering at Bolt. Foundation consists of teams that build the infrastructure for our verticals. So it's SRE team, database teams, internal tooling, and data platform. And it's worth mentioning what Bolt does because we are not present in this part of the world yet. Bolt is a super app born in Estonia and based in Estonia mostly, serving 200 million lifetime customers across Europe and Africa. We are present in over 50 countries, 600 cities, and our mission is to make cities for people, not cars. So we develop different types of products that encourage people to give up their cars for everyday usage. So that includes ride-hailing services, delivery of food and parcels, and also different kinds of micromobility, like carpooling, electric scooters, and electric bikes too.
So Bolt is more than just the Uber of Europe.
Yes, it's more than this.
Yes, a lot more. All right, Dave.
Hello, I'm Dave Burgess. I see we're going in increasing gray hair order. And so I'm actually now more consulting and advising, passing on wisdom and some knowledge. And I used to work at Pinterest for 5 years, VP of data engineering, looking after all of the online systems, as well as all the big data processing, experimentation, machine learning platform, all of our APIs. So 5 years of that, and then before that, Twilio.
Yeah, Twilio, that's right.
SendGrid. And so led data platform and machine learning at Twilio. And a little bit before that, at Yahoo during the hyper kind of growth phase, and was part of the data, which is where we started doing behavioral targeting, and Hadoop came out of there, and so we've a fair bit of experience.
Very nice. All right. Well, I am also aware, as a panel, we have become collectively aware that we are the only things standing between this audience and alcohol at the moment. So we will get right to it and hope everybody...
They're still recovering from yesterday.
So, the theme of the conference has been data at scale. And if we caught the keynote this morning, we heard our CEO of PingCap talk about what is scale and the different dimensions, different aspects of scale. So I want to, follow the format kind of past, present, and then future. And so starting with that, I want to ask the panel, in your experience, how have you dealt with issues of scale in the past, and particularly linked to how the businesses that you've been connected to have grown themselves, and how that impacted scale and created challenges that you needed to overcome, and how did you overcome them? And I'm just gonna, I guess, Dave, would you like to start? Or sorry, Lucas, would you like to start?
I can start easily.
Yeah.
Yeah, so, my journey with Bolt started like 7 years ago. The company during this time grew over more than 100 times in terms of the business, and also the data followed, fortunately, unfortunately. And we faced quite many challenges during this time. Starting from like live systems, let's say, I think the biggest challenges that we had at the very beginning is like decisions you make at the very beginning of your journey very often have to evolve, or if you don't spot the right moment, then the cost of this evolution are higher, obviously. One of the kind of evils I think, like, or the errors that I can identify and learn from the past, I think the most important one is to be always, monitoring this kind of metadata, trying to learn the patterns, like how your data is being written, what are the access patterns of your data, and because like very often the teams that work on the data on the database side or data platform side, they are not always connected together with the teams that write the code. So you have to have the tools and try to observe to predict when it's the moment to kind of give the next step. I think another problem that's was following us from the past times was depending too much on the mutable data, and making decisions like with the next products or the next iterations of the products about going more towards immutable data. Maybe the storage is slightly more expensive, but you save a lot on the complexity and on the processing of this data. Schema evolution becomes more simple and so on. So I would say that those are the two most important things I learned over this journey.
Fantastic. All right. Sean?
Sure, yeah. So I think the main takeaway is that there's data problems everywhere. And I think when you think about data problems, think about your use cases and what are the right tools to solve your problems. Because you're only going to be as good as the data that you have. So build that right, and then how do you query on top of that, right? And so just, again, speaking kind of throughout my career journey, not even just at one company, I actually worked at MapQuest for a little bit early in my career. This dates me, like my career journey also started, like now when you're talking about decades, right? My career journey started over 2 decades ago. Makes you kind of sound a little bit older. But so I worked at MapQuest when we were kind of going toe-to-toe with Google Maps. And MapQuest at the time, we were still doing 5-box search, very old traditional geocoding. Google was doing single line. And so how do you kind of solve that, like, traditional geocoding problem, but making it more like natural language and parsing the intent, making sure that, misspellings are handled and things like that, right? And so that's kind of where I started. That's a data problem. At SendGrid, so I was on the marketing campaigns team. SendGrid is a transactional email engine, so we're very good with sending like order confirmations, receipts, things like that. But how do you build a marketing campaigns email engine and build it at scale, right, on day one? So we had customers like Niantic who want to do a re-engagement campaign for like, Pokemon Go. They're coming out with their Harry Potter game, and they have 300 million contacts. They use SendGrid for transactional, but how do they actually send campaigns now to re-engage based on demographics and things like that? So introducing a data solution for that. At GitHub, GitHub is known as probably like the world's largest Ruby on Rails monolith. At this point, we spent like 12 years building that. But while I was there, like we started actually, given that we were like 1,000 people development organization, post the Microsoft acquisition, we're talking about, okay, how do we actually work, in a very organized manner that doesn't mean like 1,000 people contributing to the same monolith. So we had to look at microservices and how do we partition data and how do we break that data up in a safe manner that doesn't cause a lot of production issues. And then finally, kind of at Catalyst in our journey, so we actually started with a very simple Postgres Elasticsearch solution to just bring in all of our customers' data and being able to support their flexibility of how they query that data. But we ran into a couple of things, right? One is that every customer of ours is so very different. We have customers that manage truck and fleet management. We have customers that are, mobile solutions. We have, customers that are, doing marketing. And so everyone has different ways of, structuring their sales force. They put different data in there, different hierarchies, whether it's product or not, whether it's organized by regions, whether it's organized by product lines. But, everyone has different data. And what we've noticed that our data is getting just more and more complex because we're bringing in data from usage, from ticketing, from otherwise data warehouses. People are asking the questions of like, hey, show me all my tickets in the last X days for my European customers only that are trending this way in health, right? And so it's starting to be what we call like cross-object queries. It's starting to get very complex. And our solution with Postgres and Elasticsearch is just no longer sufficient, no longer performant, enough. And so what we kind of uncovered is that the type of questions that our customers are asking is really very similar to more of like your traditional internal BI teams, like where they put everything in the data warehouse and they want to like drive a lot of these insights and analytics. But also, those type of systems don't tend to be real time, and our customers want this web interface that's snappy and performant in real time. So that's when we started looking at kind of databases that does more, right? Like this is where our path crossed with TiDB around kind of transactional and analytics, right? The HTAP data stores. And so again, just this journey, like there's data problems everywhere. Think about what you're trying to solve and try to kind of find the right tools for solving that job. But at the end of the day, right, you're only as good as kind of the data that you have. And so that's very important.
Yeah, fantastic. Dave?
So I've kind of been fortunate in that some of the companies that I've worked with, Pinterest, Twilio, Yahoo, we're all scaling pretty rapidly. And they would scale at the rate of maybe 2 to 3x per year, which means that within 2 to 3 years, you have to be able to scale at 10x. And then 2 to 3 years after that, another 10x. And at the same time, you're adding more and more engineers to the company. And so you've got to keep your innovation going really quickly. And what you're finding is that when you start off with one database, and then you go into multiple, then you add a key value store, then you add a search, then you add analytics, then you start doing machine learning, and you start increasing the complexity. And teams, if they're not incentivized right, will start to build multiple of the similar systems. And so what's really important, what you can tell from like a really senior engineer compared to a more junior one, is to create more simplicity. Try and reduce the complexity down, and also plan for the scale, both in terms of like not just data, but also innovation velocity. So when I joined Pinterest, we were basically most of the systems were on fire. Like the production was going down every single day. We had so many transactions, we were unable to like keep it all going. And so the most important thing was to get high availability, make sure that all the system works. Have no single points of failure, make sure that all the run books were automated so that things would automatically fail over so that the systems become more reliable. And then that would free up developers to then work on other things like figuring out the next generation system to go and build. So, and over time, we looked at productivity. We like doubled the productivity of data scientists, 10x the productivity of machine learning engineers, and we figured out how to scale up things 100x. So you really have to think about where is the business heading over time so you can actually take these actions before you get to a point where the house is burning.
Gotcha. I like it. So if I'm going to just sum all this up, it's everything's always on fire, know which fires to fight, and know when to start fighting. All right, fantastic. Well, I know that in each organization, particularly the ones that you're working with now or have worked with, there's major transitions that are afoot, taking place. So what are some of the key factors that actually brought you to the point of contemplating changing the data architecture, the underlying data architecture? This distributed SQL thing is taking ground and taking off, and a lot of people are in the position that you were. So what were the factors that put you in a position of starting to consider it?
Yeah, absolutely. So again, I think for a SaaS company like ours, it's about focusing on what we're good at, right? And figuring out the fastest path of what we can outsource and just solve those problems. And so I think, for example, I used to have a team. Their whole job was to build API connectors and update those API connectors so we can bring those data in on our customers' behalf. That's not a great use of my team's time. And being, back when I joined the company, we're, relatively small Series B stage startup, that's not where I want my developers to be focused on. I want them to be building, workflow automation. I want them to be building these dashboards and insights that helps our customers solve their problems. And so that's kind of when we started looking at some of these, different technologies out there. And so again, coupled with kind of that data warehouse use case where our customers are asking more complex, deeper questions about their data. So we thought, what's out there that brings data in? And so we looked at Fivetran, and I think this is when a lot of companies were shifting, from the traditional ETL to ELT, right? And so like Fivetran, their entire business is building data connectors. We don't have to worry about like API backwards compatibility. We don't have to worry about race conditions. If somebody's seeing a different thing on their, mixed panel dashboard, what they're seeing in our data, right? And so Fivetran solves all of those problems for us, and they solve it for a lot of other people. So we're like, hey, let's use that. And then we bring that into kind of a more traditional like data lakehouse architecture, which we're partnered with Databricks on. And then, with that, that's where we do a lot of our transformations using PySpark. So cleansing of the data, validation of the data, and getting it into a state. But as we all know, like whether it's data warehouses or data lakehouses, they're not known for their transactional level performance. And this is where TiDB comes in. So this is going to be our serving layer that our actual application can be built on top of. That helps us with the, kind of the querying, both the analytical side of things as well as just, regular MySQL queries. And we do a lot of time series data, so things like trend reporting and things like that. So that was kind of the catalyst architecture. And then, businesses change, right? And so, like I mentioned, 6 months ago, we went into this merger with Tatango. And so now we're solving a different set of problems. We're looking at unification, we're looking at customers, we're looking at migration, and we're looking at how do you bring two similar products together, but yet they're slightly different under the hood, right? Like there's, we all solve the same type of problems, but we solve it slightly differently. And then what are some of the data solutions that work really well for helping us manage that transition? So those are some of the things that we're looking at right now.
Yeah, very nice. So we're hearing this term data serving layer a lot lately. And I know even internally we've talked extensively about what this means, that I mean, technically a database server is serving data, but I love your use case there where you actually showed how a data serving layer fits in as an architectural component. So, Dave, would you like to go?
Sure. And so the first thing is really gathering user feedback from both the internal users of the systems as well as external, and really hearing what issues they are experiencing so that you know whether you've got the right data systems there and whether you get the right solutions for them. And so those problems could be like data consistency, it could be is there high enough availability, it could be is the data not of good enough quality. So you really need to understand the user problems before you can go into say, what kind of system do you need. And then you need to understand the customer use cases. So how those use cases get enhanced over time, or what new use cases are coming, so what functionality is needed. And do your existing systems have that functionality, or do you need something more? And then you also need to think about, well, what's happening with the business? Do you need to scale up more? Do you need to, are you increasing your infrastructure costs too much? Are you increasing your maintenance costs? So you have to take all these things into account when you're deciding whether you want to replace a system. And so it's good to keep health check on that on a regular basis. So like every 6 months, we would do a survey of all of our customers to find out the NPS Net Promoter Score for each one of our services so that we could really understand what the customers thought. And when we first started doing that, it was horrible. The results were like, Net Promoter Score is like between -100 and +100. -100, everyone hates your service and your system, and +100, everyone loves your service and system. And so the average when it started was like -6. Some teams were -30. And so, but by every team knowing that we were going to have this every 6 months, these scores started to improve, and so they got up to 60, 65 on average. And so just having that focus was really important, and knowing where, and giving the teams the ownership and responsibility for making sure they created a great service for their customers was really important as well. So they would make the decisions on what extra functionality, what was needed, whether they would need to replace their systems, and so it just gives them that remit to do it.
Now, were these customers, were the consumers, were they internal customers or were they public-facing public customers?
For companies like Pinterest, Twilio, Yahoo, these were all internal customers. But the same is reflected on external as well. In fact, it's even more important when it's external. When you want to sell a product, you really need to know what the external customers are wanting in terms of features and capabilities, and whether the solution that you're selling.
Yeah, so when you're changing internal NPS score, I mean, you're impacting company morale.
Yeah, that's right.
Fantastic. Lucas?
Yeah, actually, I'll refer. I like this approach, about thinking about, even if you are working in the team, in the organization that maintains and builds the infrastructure, you should develop this product thinking within the engineers. Like, I think it's very often it's not very natural behavior for people who work with the infrastructure. And yeah, this product thinking and treating other teams and divisions inside the company as your direct customers. So yeah, I think it's very important to keep it into account, because like the success of this platform like Teams is when nobody knows that you are working and existing, because everything works so smoothly. So when nobody talks about you, it means like you're doing the great job.
Yeah.
So
don't know when things are broken.
Exactly.
Yeah.
So yeah, like putting like a bit of context from my experience, I think usually those decisions about changing the architecture start with a particular problem that you encounter. And it happens when you encounter the limits of the current existing architecture. So it's usually about the size of the data, about the performance of the system. So where, for example, latencies become not acceptable for the end users because it's happening on this infrastructure layer. And I think it also, in the long journey of Bolt, that was one of the factors that turned our engineers to try at least TiDB, give it a try. The situation when once we encountered like one of the biggest MySQL tables cannot be modified anymore. You cannot do any changes to the schema because there are no big enough disks in the cloud provider to actually facilitate that. And so that was one limiting factor. And the other one was scalability. So like, let's say, databases designed not necessarily for the cloud. Usually they have this problem of coupling storage and compute. It wasn't a problem if you, from the very beginning, were thinking very well about how to design your data schema so that it's properly sharded, properly divided, and you can keep splitting things so that they keep scaling. We're not so smart in the early days. So here, TiDB came to save us and providing this functionality for separation of the storage and compute.
Gotcha. And Titan is part of the storage engine underneath TiDB.
Excuse me?
You said Titan, right?
Yeah, I said TiDB.
Gotcha. Okay, great. Well, so that leads us to the next obvious question, since we're crossing into the future and after our decisions have already been made. Why TiDB? Let's start with Dave.
Yep.
What was it? And maybe for the sake of time, let's talk about two biggest things that not only led you to distributed SQL, but TiDB.
Can I do 3?
Sure, go ahead.
Okay, so we had about 50 HBase clusters, and we were on an old version of HBase, and HBase hasn't been contributed too much in open source anymore. And we had applied hundreds of patches, and we were having lots of, the total cost of ownership was huge. So we had like 4 or 5 engineers full-time just trying to keep HBase alive. But at the same time, we had lots of complaints from our customers about data consistency, that they were putting things into the user interface, and then they see another result a few seconds later. And so they wanted to just see what they'd just put in, of course, which is natural. And then we also knew that it was going to be a scalability problem. And at some point, HBase was going to fall over. It couldn't handle. We wanted to have over 1 billion ads, shopping ads within HBase. We knew they were going to have problems. So those were the 3 major factors for us to start looking at other solutions. We looked at about a dozen different solutions, and then narrowed down to, after doing some POCs, that TiDB was the best one for us. And now, of those 50 clusters, I think we're down to 8 now.
Wow.
So we've gone a long, long way, and just in the last few legs.
Wow, that's fantastic. Yeah. Lucas?
Yeah, I think I mentioned one of the reasons was like scalability, separation of the storage and compute. I think other important factors, at least in our context, it was important that the database is compatible with MySQL. Like, we have the SQL standard, but everyone knows it's not the standard. If you want to switch to another engine, I have to apply the flavor of that engine. And that was another factor. Apparently, I think there are not many solutions that are able to be compatible at the same time, offer the separation of compute and storage, and also the scalability for scale and cloud. Another important factor, I think I'm going over 2 right now, was the community and the fact that the technology is open source. So that guarantees that you don't necessarily depend on the company vendor behind it. There might be stories from the past where companies incorporated and bought by another one, and the quality and direction of the product changes. So when you have a community, that's kind of drifts slightly the gravity so that this initial idea will not drift away from there. So yeah, in our case, I think those were the most important factors.
Gotcha. Yeah. All right. Shah?
Yeah, so the way we think about it, right, I think Jeff Bezos actually said this. When you're looking at technology selection, or when you're looking at making any decision in the business, there's one-way door decisions, and there's two-way door decisions, right? The two-way door decisions, you can easily, come in, go out, change out of that pretty quickly, and you want to make those decisions pretty fast. Which features do we build? How do we build it, right? It's not the end of the world. You can always iterate on top of that. And then there's the one-way door decisions where, you're selecting a technology partner. You're looking at doing things differently from a data architecture perspective. And those decisions usually take, at the minimum, multiple quarters. In our case, actually, interesting fact, exactly 2 years ago at this conference, one of my engineers came and basically talked about a hackathon project that we did, kind of a bake-off. We looked at a couple of different vendors, different technologies for solving our problem, and he talked about his journey for how we chose it. And now, almost to the day, exactly 2 years later, 100% of our customers are now on TiDB
Fantastic.
as the serving layer. So again, this is an example of that. This is often multi-quarter, multi-year decisions, and this is something that you don't want to make lightly. And so the way that I think about it is that who are the strategic partners that we want to bet our businesses on, that we want to partner with, and we're very intentional about selecting those partners. So to provide an example, Databricks, right? They're actually an investor in Catalyst because they just love our use case. We're not just using them as a back office, data store, data warehouse. We're literally building a CDP for every one of our customers, and we're doing it in production. And they love that, and we're using their architecture for doing that. We're actually one of the first companies that are in like the non-data, non-dev tooling space that Databricks has invested in. Similarly, for Fivetran, right? We're a Fivetran customer, they're a customer of ours, and we have a very strategic partnership there. With TiDB, we're actually probably one of the first adopters of TiDB Cloud here in North America. And I think the way we look at it is, how strong is the community, right? And how healthy is the ecosystem of people contributing to this? And are my developers excited about this technology? And in this case, this actually came from one of my developers. He's like, hey, this is like different than everything else I've seen out there. Let's actually, include this in our bake-off and, prove this out, right? And, ultimately, how much, everyone is willing to partner in this, right? And so we felt very good about, being one of the earlier cloud adopters, being part of the customer advisory board, hearing what you all have planned from a product roadmap perspective, knowing that we have the enterprise level support of people who are going to basically be with us for this 2-year journey and get us there 100%. And that's really important for us.
Fantastic. And I was here actually that was actually our very first HTAP Summit. And if I remember the story correctly, it was 9 engineers locked in an Airbnb with the instructions of don't come out until you have a solution.
I don't think they were locked. I stocked that fridge very well. I made food runs.
Very nice. Well, so many of us have been to the CAB meetings. We've heard sort of the future of TiDB, and we've taken input, and we've really tried to gain a lot of benefits out of the experience of our customers. Outside of that, with your experience in the industry, where do you see the future of the industry going as we evolve into the next phases of it? And what are maybe one of the challenges you think that we have to overcome as we evolve? Do you want to start?
Yeah, so the way that we think about data, right? So we started with kind of you're only as good as your data, but what can you do with that data? How do you unlock the information in that data? So the way we think about it is like there's data, there's information extraction, there's insights, and then you get to knowledge and you get to wisdom, right? And how do we basically help our customers get more and more out of their data in this process, and tying that to our business proposition, tying that to our business value. And I think everyone is starting to realize the value of data, right? This is why we have so many data providers. Everyone's like, hey, use our data warehouse this, use our data services this to kind of get insights, right? So just having that data in one place, having it clean, having it validated is no longer enough. You need to be able to drive action. You need to be able to give additional insights to your customers. And now, with a lot of the latest development in like large language models and Gen AI, right? So as a business, we have to adapt and we have to kind of figure out how to leverage. Is that new tools we're introducing, or is it existing ecosystems now that we can build these models on top of? And so for us, up until this point, we focused a lot on more quantitative data, right? So things like that, product usage data. Are your usage going down? Is that going to lead to churn or risk? Are you ripe for expansion? Like, what does the trend say based on, your Salesforce numbers and your revenue and all the other business factors, right? But now we also have, a ton of language data that we're sitting on. Right? So think about all the email exchanges that you all have with your customers, whether it's from account representatives or CSMs. Every call is now recorded on Gong or Clary, or there's like a lot of like logs that's available, right? And so this is like a really good time with the power of like large language models and Gen AI to start thinking about how do you start extracting sentiments out of those calls. So it's not just, hey, quantitatively, these numbers are telling a story, but like, hey, that call in the last like 3 or 4 interactions, you've had with this customer, like the tone changed. Something in that, like, there's certain words that are used, or maybe your champion left, right? But now there's cues that you can pick out of that language data that really tells you, like, hey, out of the last like 10 interactions you've had with your customer, maybe half of them were not as positive as you thought. And those are early indicators for like, hey, maybe this is a time to lean in and do something about it, right? To really drive that action and insight.
Keep our sales teams honest.
Yeah, so I think there's a lot of opportunities here.
Nice,
Yeah.
okay. Lucas, what does the future look like in your mind?
I'm very pragmatic. The only thing I believe in the future of data is RAS, so reliability, availability, security, and also better scalability. So basically improving the existing solutions such a way that they are so reliable, so easy to use, that you forget that they exist, including the invoice that you get at the end of the month because they are so cheap to use. I think that's the basic, and having that, that also opens up new use cases so that people who are in the past, right, you had to be know how the computers work inside, know the programming languages to be able to use the computer 30, 40 years ago. Now the kids like almost do it intuitively. So I see the future this way, that people who have not much idea about the data, about the challenges it brings, are able to create insights from data because the tooling is so simple and so well adapted that anyone can basically use the data.
Gotcha. Very good. So democratized access. Everybody's an analyst now.
Yeah.
Well, everyone can use ChatGPT.
Yeah, that's
Well,
true.
text to BI, text to SQL,
Yeah.
There's a
Absolutely,
lot of that. Yeah.
absolutely. So Dave, given your position and where you are today, a lake house may or may not be in your future, but that's probably a different topic.
Yeah.
So where do you think is the future of data?
Well, I very much agree with Shah and
Yeah.
Lucas, actually. So, and I would actually go maybe a few steps further. So with the data, you're definitely going to be able to do sentiment analysis, and large language models are going to be run within SQL databases. So you're actually going to do some large language on the columns of the database. And there's also going to be some automated things like automated anomaly detection, automated figuring out what the root cause of problems are, so that you can, what the patterns of behavior are, and give suggestions back to product, back to the business on things that they should change, either about their product or about how they interact with the customers, in order to improve the amount of sales and the amount of usage. And so that, I think products are going to come off the shelf to do that. There are already startups that are doing that, and they're obviously going to grow. I think there's also going to be a lot more scale. Like TiDB scales pretty well now, but there are customers that want even higher scale. And so TiDB probably have to 10x, 100x the scale. And that's going to be a challenge. But at the same time, for distributed SQL, the distributed SQL can take more market, could take more of the key value store market, for example, and all you need to do there is lower the latency, increase the number of transactions per second, maybe remove the ACID compliance piece for some requirements, and so could take more of that market. Could also take more of the analytics market, having the data in the same repository. You can build other real-time analytics capabilities of the storage, just like we did with HDFS, Hadoop file system, but on a real-time scale. And then I think with large language models, the knowledge graph or the graph RAG is going to become more important because that's got more accurate data. So you're actually looking at the relationships of things, and so having a graph capability is going to become more and more important, and more data will be stored in graph form and then be leveraged through graph form. So those are three on the online side. I've got more on the offline side, but those are three on the online side.
Yeah, nice. I know that it's taking me back to the mid to late 1980s. There was another distributed SQL company, and at the time, it was thought that a terabyte was impossible. So one of the things that I'm learning over my experience and from listening to you is that those size barriers are never a permanent barrier. They will get knocked down.
Yeah.
Eventually.
Yeah, they will.
Well, somehow throughout this entire thing, we actually managed to time things well. And we have actually reached the point where we have a couple of minutes for some questions, if there's any questions from the audience for the panel. And if not, keep in mind that the first question is the first impediment to a beer.
No pressure.
No pressure. Go ahead.
Question: if there were like prospective users of TiDB in the audience, what would be an advice that you would give them?
So the question is, what advice would you give to somebody who's contemplating TiDB and in the audience are watching this?
Yeah, I mean, I would say, think about your business use case, tie it to the value of the business. What problem are you trying to solve? Think about, why this is the right solution to make sure that there's a good match, right? So don't just select the technology for the, for the buzzword or because your developers wants to try something, new and interesting, right? Like, those are obviously good reasons, but tie it to your business value and the problem that you're trying to solve.
I like that. And I've said before in other contexts that it is possible to have a fanboy mentality at the enterprise level. And that's just not aligned with business. We're in this business, we're in the data business to serve a purpose for the companies that we're a part of.
Yeah.
Do you have an idea?
To add a bit of this, I completely agree with Shah. It's also think about the scale. If you think that your business will be really huge and will grow, or the particular use case that you have, then consider the TiDB for this purpose. But if you want to have it as a, let's say, separate cluster just for one of the microservices that is doing some background small job, that probably is not the best use case.
Yeah.
So think about the scale, but definitely if the scale is like of the orders of tens of terabytes in the next 12, 24 months, TiDB definitely should be one of your top options on the list to check.
There you go. Any comments?
I
Dave?
agree with both of them, but I would add one more thing, is that I would reach out to PingCap. PingCap was a fantastic partner for Pinterest and really enabled us to deliver much, much faster with getting their advice and their help. And so, well worth giving them a conversation.
Very good. Any other questions? I've got one thing that actually, you brought the idea out, and I'm thinking back 7 years ago, and this term polyglot came out. And your presentation earlier today, talking about all of the different databases that ended up getting created for different business purposes. You don't hear that term thrown around too much anymore. And I think it's because of use cases like what you pointed out, that we now have platforms with these new capabilities, and so we have the ability to collapse them down. Part of the reason for Polyglot and putting a different database under each service is because each of those databases did like one thing really well, and every single one, it was a different one thing. Yeah. So folks, thanks for attending. I'd like to ask, can we get a hand for the panel here? Fantastic.
Thank you.
So thank you, each of you, for your time and sharing your wisdom with us. And with that, there's going to be refreshments outside, and feel free to grab our panel members if you want to talk to them offline.
Thanks for having us.